All right, so in this example, we're trying to prove that tan theta minus cotan theta is equal to this fraction, sine squared minus cosine squared on top, and sine times cosine on bottom. So if we're going by the rules of which one's more complicated, I think this one's open for debate. The one on the right definitely has more stuff on it, but the one on the left does have tangents and cotangents. Um, I'm just going to go ahead and choose the right side on this one, just because it does display kind of maybe a different way of thinking about it than we've done in some of the previous examples. So as I write this out, I'm thinking about what are the differences between what I've got on the right and what I have on the left. And oops, I don't know where tan came from, excuse me. There we go. And the thing I notice is that we've got a single fraction on the right and two different terms on the left. All right, but let's remember that, if I say, something like this, x plus 6 all over 3, we know that we're allowed to take that 3 and put it under each of those terms separately, right? So that might be a good thing to do here. So I can take the sine squared of theta and put it over sine times cosine. And then I can take the cosine squared of theta and take it as sine times cosine. Right? And just a little note here, notice that we do not have the Pythagorean identity, right? The Pythagorean identity says sine squared plus cosine squared equals 1, right? So we're definitely not going to be using that. So we go ahead and split them up, but then we can see there's some nice cancellation that happens here. So here I can cross out a sine theta on bottom and be left with just a single sine theta on top. And I can do the same thing with cosine in the right-hand term. But if you look at where we're at, we're actually pretty much done, right? Because if I have the sine of theta over the cosine of theta minus the cosine of theta over the sine of theta, then I end up with the tangent of theta minus the cotangent, the cotangent of theta, which is my left-hand side.